Okay, so Junior Roberts here. We're looking at this question. So this is a CAPE physics question on the topic of projectile motion. So let's see what it says here. So we can see we have a scenario illustrated by this diagram, but the question says that a tennis player standing 12 meters from the net of height 0.9 meters serves a ball horizontally at some initial velocity u at a height of 2.5 meters. And the question wants us to ignore the effects of air resistance, which is something that, we're almost 99% of the time going to be considering that air resistance is negligible, or we're going to ignore air resistance, because that just makes the question a lot more manageable. All right, so here we have now, it says we're to calculate the initial velocity u of the ball if it just clears the net. So if we look at our scenario right here, so we have a tennis player who is going to serve a ball, and the ball is 2.5 meters from the net, and the distance of the player from the net is 12 meters. And we were told that the ball was launched initially horizontally. Now, we want to find the initial velocity. So let us say we consider the horizontal motion, right? And we're going to realize that, or we're going to see that whenever we look at projectile motion, we can actually consider motion in two dimensions. So we can consider an horizontal motion as well as a vertical motion. And also remember that both motion, or motion in both planes, take place simultaneously. So let's say we look at the horizontal. So let's say we look at the horizontal motion, right? So we have the ball. It's going to travel horizontally from this position until it reaches the net, right? And we're told that the displacement from the player to the net is 12 meters. So let's just put down some variables in the horizontal motion. So we will have our displacement s, which is 12 meters, right? We're also going to have, u in this case is the unknown, which is what we're trying to find, right? We're going to see that since the object was launched in horizontally, we're going to see that the angle with respect to the horizontal is going to be 0. And also, we're going to see that in this case, because the motion is taking place horizontally, we're going to see that in this case, our acceleration is going to be 0. Because remember, when an object is undergoing projectile motion, it is under the influence of gravity. And gravity only acts in the vertical. So only the vertical motion is affected by gravity. So in this case now, we see that we can actually consider an equation of motion, because we have s, we have u, right? And also, in this case, t, right, would be a unknown, right? So we have u and t being our unknown. So in other words, in order for us to consider this equation, or consider the horizontal motion, we need to know the time as well as the initial horizontal, or the initial velocity. So now, we're going to consider that s is equal to u. Since we're looking at the horizontal motion, we're going to have u cosine theta multiplied by t. But again, u and t are unknowns. However, we can take the fact that in projectile motion, we have the object moving in the horizontal direction as well as the vertical direction, and we can consider that the time for the object to move vertically will be the same time that the object will be take to move horizontally. So let's look at the vertical motion to see if we can determine the time of travel in this case. So this is our vertical motion, right? Now, again, with the vertical motion, S, let's put down some variables, S in this case. So the object will be moving from 2.5 meters down to 0.9 meters. So we can consider that, okay, the object will be going down. So let us say we define down as negative. So down is considered negative. So in this case now, the object will undergo a negative displacement from 2.5 meters to 0.9 meters. So let's see if we can actually calculate that displacement S. So S then now is 2.5 minus 0.9 should be 0.9, right? Which would work out to 1.6 meters. So our displacement is 1.6 meters negative. So this is negative 1.6 meters. Again, because the object is moving downward. Now, in this case now, our acceleration A is just minus g, right? The time is what we're trying to find. And in this case now, since the object was launched horizontally, we're going to see that our initial vertical velocity is going to be 0 meters per second. So for the vertical motion, we can write that S is equal to u sine theta minus a half gt squared. Now in this case, because our initial vertical velocity is 0 meters per second, this entire term would go to 0. So this goes to 0. So what we're going to be left with then now is going to be left with S is equal to minus a half gt squared. Now in this case now, S we said was minus 1.6. We're going to have minus a half. G is 9.8, and we multiply that by t squared. So now we can do some simplification, right? So we can do some simplification in order to find t. So notice that we have negative on both sides, so we can actually divide through by negative so that the negative cancel. And we're going to have 1.6 equal a half multiplied by 9.8. So let us say we evaluate half of 9.8. So 9.8 divided by 2 would give us 4.9 t squared. So to find t now, we need to make t the subject. So we're going to have t squared is equal to 1.6 divided by 4.9, which we're going to get from the calculator. So let's use the calculator. So we could say 1.6 divided by 4.9, and we're going to get 0.33, right? Now, in this case, we're trying to find t. So we just found out that t squared is 0.33. So now, to find t now, we just take the square root here. So t then now would be equal to the square root of 0.33, which works out to be 0.57, written to two sig figs, 0.57 seconds. So that would be our time for the ball just to reach the net after it would have been served by the player. So this value right here is the time it takes. So what we just see is that it's going to take 0.57 seconds to go from here and reach the net. So again, remember, as we said before, that the time in the vertical and the time in the horizontal is the same. So we can consider then now that, okay, if it takes 0.57 to go from here to the ground, it will also take 0.57 to go from here to the net. So we get our time for it to reach the net to be 0.57 seconds. And again, this is the time that we calculated in the vertical. But we said before that the time for the travel in the vertical is the same as that for the horizontal. So in other words, it takes 0.57 seconds to go from 2.5 meters down to 0.9 meters. So if it takes 2.5, so if it says 0, so if we take 0.57 to go from 2.5 to 0.9 meters vertically, it will take that same time to travel horizontally from the point of serve to the net. So then now we can now use that now to help us find the initial velocity. So in our equation right here, we have s is equal to u cosine theta. So now we can start to substitute the values in our equation right here. So s is 12. So s is 12, and that is equal to u, which is our unknown, multiplied by cosine of theta, which is 0, multiplied by our time t. Now the time we just found out is 0.57, so we say 0.57. Now we can start to simplify, so we're going to have 12 is equal to u. Cos of 0 is 1, so we're going to have 1 times 0.57, so we get u multiplied by 0.57. Now, because we're trying to find u, we can divide here by 0.57, divide here by 0.57, and we're going to see now that u will be equal to, taking the calculator, we say 12 divided by 0.57, and we get an answer of 21 meters per second. So that would be our initial velocity, 21 meters per second. And again, this velocity is initially horizontal, or the object is actually projected horizontally. So this is our initial horizontal velocity, because again, it has no velocity in the vertical direction. All right, so that's that. So let's see now part B. So part B says we're to determine the time for the ball to hit the ground behind the net from the moment it leaves the player's racket. So we need to find the time for the ball to travel here and actually hit the ground. So we can consider motion in the vertical. So for our vertical motion again, for our vertical motion, we can write that S is equal to u sine theta t minus a half gt squared. And again, in the vertical, our initial velocity is 0. So this value would actually go to 0. So we're going to have s is equal to minus a half gt squared. Now in this case now, s is the displacement from the initial point to the ground, which is 2.5 meters. So s is 2.5 meters, right? And again, if we consider that down is negative, this, since it's moving down, is going to be minus 2.5. Now, g, in this case, is minus 9.8. So now, we're going to have minus 2.5 is equal to minus a half. G is 9.8 multiplied by t squared. So now, let's simplify. So we have minus 2.5 is equal to half of 9.8 is 4.5, and again minus 4.9, and we multiply by t squared. Now what we see now is that we have negative on both sides, so we can divide 2 by negative and negative cancel. So we get 2.5 is equal to 4.9 multiplied by t squared. So now, if we divide here by 4.9, we also divide here by 4.9, and we see that t squared is equal to 2.5 divided by 4.9. Now again, we're trying to find t, so we take the square root here, and we're going to get now that t is equal to, taking the calculator, we say square root of 2.5 divided by 4.9, right? And we get a value of 0.71 seconds. So this would be the time it takes for the ball to travel from the player's racket until it hits the ground behind the net. So that's B. So let's see now what's next. So the next question now says we need to find out how far from the player does the ball land. So now that we have the time it takes for the ball to travel from the 2.5 meters above ground to the ground, right? We can use that to help us because again the time for the object to travel vertically is the same time it's going to travel horizontally. So here now we want to find the horizontal distance from the player to the point where it hits the ground. So let's consider in this case, we're going to have to look at the horizontal motion. So in this case now, we will have S is equal to U cosine theta multiplied by T. And again, in this case, acceleration does not affect horizontal motion. So we will end up with this expression. So now, S is what we're trying to find. So U now is our initial velocity. And the initial velocity was 21 meters per second. So we get 21 multiplied by the cos of 0, multiplied by the cos of 0, right? And we multiply by time, which we worked out a while ago, to be 0.71 seconds. So this is 0.71 seconds. So now, taking the calculator now, we can evaluate this. So we can say 21 times cos of 0 is 1. So that's 1 multiplied by 0.71, which works out to be 14.91, or we could round this to 15 meters per. Well, not this displacement we're trying to find, so this is 15 meters. So this is 15 meters. Now, the next question now says we need to find out, okay, what is the magnitude of the ball's velocity just before it hits the ground. So we want to know what's the velocity of the ball just before it hits the ground at this point. Now, what we can start with, we can start with the fact that, okay, in the horizontal plane, the velocity is unchanged because, again, gravity does not affect the horizontal motion. So what we're going to see now is that, let's say, Vx, which is our horizontal velocity, before, right, and our horizontal velocity after will be the same. Now, the horizontal velocity before is U cos theta, right? U cos theta. So this now is U again was 21. We take the cos of 0. So obviously we get 21 meters per second as the initial horizontal velocity. So therefore now the final horizontal velocity, let's say this is Ux. So let's say we'll call this Ux. So Ux is 21, and again it remains unchanged. So Vx will also be 21 meters per second. So now what we need to do now is we need to find the vertical velocity, the final vertical velocity. So for the vertical motion now, let's do it right here. So for the vertical motion, we can consider the equation of motion where we say v squared is equal to u squared plus 2as. Now in this case, what we're going to see is that we're going to have v squared is equal to u squared, where u squared is u sine theta, and we take the square of that, right? Now what we're going to see now is that our acceleration now is going to be due to gravity, so we could have minus 2gs, where s in this case, so let me just put in the values. So this is gs, so let me just substitute the values now. So we're going to have v squared is equal to, so again remember the object had 0 initial velocity, so this would go to 0, so we're going to have minus 2g is 9.8 And S is the vertical displacement, which from our diagram is from here to the ground, so it's 2.5 meters. So this now is 2.5 meters. So now, taking this a step further, we're going to have v squared is equal to 2 times 9.8 times 2.5. Let's work that out. So 2 times 9.8 times 2.5 gives us an answer of minus 49 meters per, well, let me just put the unit as it, so minus 49. Now we take the square root, so let's say square root here, and we're going to take the square root of 49. Now the square root of 49 is just 7, so v then now is going to be 7 meters per second. And again, this is negative because of the direction, because remember, initially, we defined that down is negative. So the final velocity, just before the final vertical velocity, just before it hits the ground, is 7 meters per second. So this is Vy. So now, what we're going to see now is that our final velocity, just before it hits the ground, will be V, which is equal to the square root of Vx squared plus Vy squared. So now, Vx is 21, so we say 21 squared plus Vy, which is, we're just going to say, take the magnitude, which is 7 squared. So now, what we see now is that V is equal to the square root. Let's do this now. So we have 21 squared plus 7 squared, which we know is 49. So this is 490. So we take the square root of this now. So let's square root 490. And we'll get a value of V is equal to 22 meters per second. So that would be the final velocity just before it hits the ground. So again, this was Junior Roberts with realjuniorroberts.com. If there was anything in this video that you wish to get further clarification on, then post it in comments and I'll do my best to clear up any misconceptions. Like this if it was helpful and click subscribe on the bell so you're notified whenever I post new videos like this. Thank you for watching.